Because I look at that to study, you know.
Okay, good.
I really do.
Good.
No, he doesn't. Yes, I do, dude. I didn't do a single homework assignment last unit. Totally didn't even know what was going on. Then I looked at that morning of the test.
And it helped?
I felt so good about myself.
Good. All right. Bottom heavy and same degree are the ones we are graphing today. So if you take a look really quick at the shortcut that we had the other day, bottom heavy and same degree, are those the two I said we're dealing with? So what kind of horizontal asymptotes are we going to end up with? Either y equals 0 or y equals a number like 1/2, the leading coefficients. We will not end up with what? D and E. Top heavy we save for, actually we will have it today, but not in this lesson. Top heavy will be the next lesson. What happens when it's top heavy? That's when we have our slant asymptotes. Got it? All right, so slant will be our second lesson. For today, it's just these two. For the first lesson, it's just these two. All right. Number 1. Y equals x plus 2 over x plus 3, x minus 3. And that's it for now. We are learning some new stuff when we're graphing, so you really want to make sure you're paying attention, because if you're not, and then you try to come in at the end, it will get confusing. So make sure you are paying attention, you're focused, and you know how to do this, because this trick that we're going to learn today works throughout the rest of the lessons as well. Okay, are we ready? D, what does D stand for? Va, ha, what does va and ha stand for? Good. Vertical asymptote, horizontal asymptotes. And then we are going to have our x-intercepts, which you found yesterday in homework, and y-intercepts, which you did not find, but we know how to find. It should not be a problem. All right. Are we ready? Okay. Domain. What makes the bottom 0?
That's 33.
Cannot equal, I heard -3 or 3. If you put plus or minus 3, is that okay? Yes. All right. Vertical asymptotes. What? Oh, is there any reducing to do? No. Okay, vertical, x equals, can I put plus or minus 3? No, x equals -3 and +3. Horizontal, we take the limit as x approaches infinity. And what happened? Is it top heavy or bottom heavy, or the same? Bottom, which means y equals 0. X-intercepts, I'm going to let you do that really quick. Set your equation equal to 0 and solve. Set your equation equal to 0 and solve. What did you get? -2. Did anybody get that? Like, just look at it and know it's -2 without doing any work? I see about 2 or 3 or 4. What did you do? Good job. The bottom's always going to cancel out and get 0 on the other side, so you're just left with 0 equals x plus 2, -2. Good job and good job. And there were a few other of you that did it as well. Make sense? All right, y-intercept. How do we find the y-intercept? We make x equal to 0. So y equals 2 over 3 times -3. Do you guys see how I did that? Plug 0 in. 0 plus 2 is 2. 0 plus 3 is 3. 0 minus 3 is -3. So what's the y-intercept? 2 over, so -2/9? Yes or no? All right. And we are ready to graph. This first part here is review from, you guys did this last year? Yes. All right. So review from last year as well as review from yesterday's homework and notes. All right, we are ready to graph. We will still be using our cross and bounce method that we've done before. When Nick had set this equal to 0 and he just looked up there, the x plus 2, and he got -2 for the x-intercept, is that a cross or a bounce? Cross, because the multiplicity is 1. So put a little note there. I always get asked, what about the y-intercept? Is it cross or bounce? You never bounce on your y-intercept. You just go right through it. All right. All right, there are some shortcuts we're going to use. There are some times where it takes a little longer, but you want to make sure you're paying attention and understanding. Okay, first off, I'm going to draw my vertical asymptote. X equals -3. So I go over 1, 2, 3, and I draw a vertical asymptote. Do you agree that's the line x equals -3? Yes? Then I go to x equals +3, and I draw a vertical asymptote there as well. And where's my horizontal asymptote? 0. Do you agree the x-axis is the same as the line y equals 0? Yes? All right. Let's plot the intercepts. X-intercept is -2. Is that the only x-intercept? Mm-hmm. And then the y-intercept is -2/9. Is that, should I go down further than -1? No. All right, that's all we have so far. Do you agree? Okay. Let me explain opposite direction and same direction. Okay, so let me just show you some pictures really quick. Do you see this vertical asymptote right here? Can you see that this line is going up and that line is going down? Can you see that they're going in opposite directions towards that red line? Versus, okay, let me show you another opposite. Can you see that these two are going in opposite directions towards that same red line? This one's going up and this one's going down. Okay, this red line, what do you notice about the two? They're going the same direction. Whether they're both going up or both going down doesn't matter. They are both going in the same direction, where these two are going what? Opposite. Do you see that? Okay, so I just want to make sure you understand the difference between opposite direction and same direction. Do you guys understand it? Yeah. All right. With that being said, we're going to talk about how to figure out whether they're going in opposite direction or same direction. All right. So this is for you use your vertical asymptotes, obviously, because that's what we were just looking at. Okay. For your vertical asymptote, if the multiplicity is odd, opposite directions. All right, I'm going to just write that down for now, and I'll explain a little more. We at least know what opposite direction means. And same thing here for your vertical asymptote. If the multiplicity is even, it will go in the same direction. Okay, so what does that mean? Let's write it down for now. Austin, put that away, please. You're taking notes with the rest of us. All right, what does that mean? First off, where do I find my vertical asymptotes? Where do I look to find them? Denominator. So these will always be coming from the denominator. Vertical asymptotes will always be looking in the denominator. X equals negative 3 came from this guy right here, correct? Yes or no? What's the multiplicity? 1. The x equals 3 came from this one here. What's the multiplicity? So they are both even or odd? Odd. So I'm going to put a little note up here. I'm going to put the word odd. And then as we graph, we'll see how that helps us. I'm going to repeat that. If you didn't get it, I'm going to repeat it one more time. All right. Vertical asymptotes always come from the numerator or denominator? Denominator. So I look here. X equals negative 3 came from this one, and the multiplicity was 1, so it's odd. X equals 3 came from this one. If there had been a square here, I would say that this multiplicity is even, and I would put an even here instead of odd. Got it? Okay. Questions on the vertical asymptotes? When you're looking at your cross and bounce stuff here, where are you looking at, the numerator or denominator? Okay, so put a little note to yourself. This is the numerator. This is the denominator. All right, vertical asymptotes, you're looking for your multiplicity in the denominator. The x-intercepts, you're looking for your multiplicity in the numerator. All right, are we ready? Okay, do you guys agree we have 3 sections to our graph? The left side, the middle, and the right side. Left side, middle, right. Yes or no? Okay. Now I have no x-intercepts over here. Do you see that? Okay, so I'm going to, I always start at the left. I go left, middle, right, in that order. Starting at the far left. Because there are no x-intercepts, we are going to have to plug in some numbers. Now I do want to tell you this. What we do know for sure is that our graph approaches the asymptotes. And since there are no x-intercepts, it's either, don't draw this with me because I'm going to erase it, it's either going to be like this, all at the top, approaching both green lines, both asymptotes, or all at the bottom, approaching both asymptotes. Do you see that? Why can't it be at the top and the bottom? Because then it's not a what? It doesn't pass the vertical line test, which means it's not a function. So can it be all at the top and all at the bottom? It's either one or the other. Does that make sense before I go any further? Okay, so I'm going to repeat that. We know on this side it's either all top or all bottom, and there are no x-intercepts here, so there's no like moving things around. It's either all at the top, all at the bottom, and not both. Questions on that so far? Yes? What does that even mean? It means we need to figure out, is what it means. We need to figure out whether it's all top or all bottom. Anyone know how we figure that out? Plug in numbers. That's what I said earlier. So we plug in an x value. Now, if I'm trying to figure out what's going on this side, should I pick x equals -1? X equals +5. What value, what kind of value should I pick if I'm trying to figure out what's going on this far left side? Something to the left of that asymptote? 1, 2, 3. So can I pick -3? So -4, -5, -6. So x equals -4, and you're going to plug it into this function here. What are you trying to see? If it comes out to be positive or negative. If it's positive, where's the graph going to exist? All on the top. If it comes out negative, where is it going to exist? All at the bottom. And all you really care about is whether it's positive or negative. I don't care what the value is, just positive or negative. So go ahead and do that now. Anybody have it yet? I hear one negative. Some of you still working? Negative. Anyone else? Negative. All right, I'm going to show you when I do it, just a quick like little cheat method. You don't have to do this. But remember when we used to do the test values and all we cared about was positive or negatives? Do the same thing. What's negative 4 plus 2, positive or negative? Negative 4 plus 3, positive or negative? Negative 4 minus 3, positive or negative? And 3 negatives are going to make a negative. Do you guys see that? Now you don't have to do it that way. That's just a little. That's why I do it, to make things go faster, especially if I was taking a test. Your choice. If you want, like, well, those of you that actually plugged it in, what did you get? Negative 2. Negative 2 over 7. All right. Does it matter that it's 2 over 7, or just that it's negative? All right. So all at the top or all at the bottom? All at the bottom. Zach, to answer your question, because you did ask earlier, what does that mean? Does it make a little more sense now? Or still not yet? No? All right. So when you're graphing these, what we know about these graphs, if you look at the asymptotes, they're always going to approach asymptotes. Either top or bottom, we don't know until we start plugging numbers in and using our intercepts. But we know that's the nature of the graphs. They always approach. Do you see that, how it's always approaching the horizontal and the vertical? So with that, on the far left side, we don't know anything other than it's either all at the top or all at the bottom. And how do we figure out which half it is? Plug something in that's in this region. So x equals negative 4 or x equals negative 5. Any negative number to the left of negative 3, plug it in and it's going to come out to be negative. Did anybody use a number different from negative 4? No? All right. Questions on that? None? Okay. So, yeah, it's not working. It's, well, I don't know if it's working now, but it was 60 this morning, and it hasn't.
I know it's cold this morning. I think that's why the heat's not being as hot.
Yeah, I'm not too upset because it is going to be warm later.
Yeah,
So
that's what it is. I'm going to check the work control and find out
so
what's going on.
I don't need it on, is what I'm saying. Yeah.
I'll double check with them.
Thank you. Okay, so now we're going to use, in this middle region, do I have intercepts? Yes. Usually it's just the far left that you have to plug in a value. Everything else will work out because we have this tool right here, odd, which means I'm coming from the same direction at the bottom or opposite. Odd means opposite direction. So I know I'm coming from up here. I know that much. And I'm coming down and doing some stuff in here. Before I do the rest, does everyone see how I know I'm coming from the top half? Yes? All right. Now, the other tools I use are my intercepts. This x-intercept is a cross or a bounce? Cross. Now, I know I have to cross this, I have to touch this, and I have to approach this asymptote. So, when I come down and I cross and I hit my intercept, is there anything bringing me back up to make up a U shape? No. Do you see how there's no more x-intercepts over here? So is there any way, if I wanted to come up and do this? Yeah. I'm forced to do what? Down. Okay, so do you see how once you do your first test value, the rest of it works out on its own? Okay, I'm going to repeat that. How do I know I'm coming from the top direction and not the bottom? Odd, so it's opposite. How do I know I cross this x-intercept? It's a cross, it's a multiplicity, that's 1. And I hit my x and my y-intercept, and how do I know I go downward and not upward? There's no what here? There's no more x-intercepts here. If I wanted to go up, could I? I can't just make it go up because I want it to. Do you see how I'm forced to go downwards from there? Yes? And that's not always the case. There are some that are U-shape and they go upward. Questions? Yes? It is. It is because I'm explaining everything, Leonard. When you're doing this on your own, I'm not going to be talking in your ear. Are you going to take this long? I hope not is correct. All right. And this stuff is new. This whole, the green stuff I added here, this is new. And this we will be using. What was that? Oh, no. Oh. All right. Guys, on this last piece, we're going to use, okay. First off, do you agree there's no x-intercepts over here? Right. correct? Which means, again, I'm either all top or all bottom. I don't need to use a test value anymore because I have this hint here. What does this say? Means same direction or opposite. So if this one's going down, my right piece will be all top or all bottom? All top, because it's in the opposite. And you're done with the graph. Questions? Yes? The horizontal asymptote is this line right here. And can you see these pencil markings? They go towards the green line. Well, you can't really see it, but this horizontal line, they go towards it. Do you see that? Yes. So the horizontal axis is just telling you that this line goes towards it. It doesn't cross it.
So just the outside line, the middle line is not.
Okay. Now, I'm glad you asked that. He said just the outside, but the middle's okay. Listening. Horizontal versus vertical. Okay. These vertical asymptotes here, you will never ever cross or touch. I'm going to repeat that. These vertical asymptotes, you will never ever what? Cross or touch. Horizontals, you only cross or touch if necessary. Outside, is there any reason to cross that asymptote? No. So we don't. We stay all at the bottom. On the far left, is there any reason to cross this asymptote? No. So we stay all at the top. In the middle, was there a reason to cross that asymptote? There was. What was the reason? There was a what? An x-intercept. And then that y went, and then there was no reason to come up, so we went down. So, one more time. Verticals, do you ever cross?
No.
Horizontals only when needed, necessary. Got it? Yeah? We'll get more practice, I promise. No. Number 2. All right, you guys, I will not take that long again on a problem because that was the first one. It was all the little baby steps. Good. Thank you. All right. Domain, all reals where x cannot equal. I'll let you figure that out. X cannot equal what? All right. Vertical asymptotes. I'm going to start my graph a little bit. I'm going to have you do the same because we're going to add things as we go. All right. What did you guys say the vertical asymptote was? X equals -1. So when I graph that in, I'll use red this time. When I plot this in, we have to do our odd-even business. Do you guys agree? Where do I look? Where did this come from? The denominator. What is the multiplicity? What does that mean? Odd or even? Odd, so I'm going to put a little note here. What does odd mean? Same direction or opposite? Opposite. So these are either going to be going this way or that way, like up and down or down and up. Got it? All right, horizontal. How do we find the horizontal? Top heavy, bottom heavy, same. The limit as x approaches infinity. And what is it? Bottom heavy, which means what? Y equals 0. X-intercept, find it, make the equation equal to 0. If the variable goes away and you're left with 0 equals 3, does 0 equal 3? So what do we say for x-intercepts? None. Does everyone see why it's none? Yeah. All right, I'll show it over here. We do 0 equals 3 over x plus 1, and you multiply both sides by x plus 1. And what happens with the x plus 1's here? And there it multiplies to 0. And 0 by itself, does it equal 3? No. So what does that mean about your x-intercepts? There are none. All right, y-intercepts, how do we find the y-intercept? Plug in 0. 3 over 0 plus 1 is 3. 1, 2, 3. All right. Now, I didn't draw my y equals 0, but it's right here. And do I have 3 pieces here or just 2. Left and right. Do you see that? Left side, right side. Yes? All right. Since there are no x-intercepts there, I have nothing to guide me, nothing to help me. All I know it's what? It's either all top or all bottom. And how do I know which half it is? Plug it in. What x value could you use on this one? -2. Would -1 have worked? No, because that's your asymptote. So plug in -2. You're just checking if it's positive or negative. What is it? So all at the top or all at the bottom? Bottom. And after that, you don't need to plug in any more values because this is going to help you and your intercepts. Odd tells me what? Same direction or opposite direction? And does it make sense that I'm opposite as well as I have that intercept up there? Yes. And do I have any x-intercepts? No. So I'm going to do this and approach the y equals 0 line like that. Stop. All right. Exactly. It is. Okay, are we good? Okay. Questions on that one, yes or no? A little easier? Okay. Number 3. Y equals 2x plus 1 over x plus 3. D, fa, ha, x-intercepts, y-intercept. If you don't have this down yet, that's fine. I'll put it back. But really quick on this one, what did we say? The vertical's okay to cross, or you're never going to cross? And the horizontal only when necessary. And did we cross this horizontal on this one? No. This one we did because of the x-intercept. This one we did not. There were no x-intercepts. All right. Go ahead and fill that one in. All right, if you haven't made your x and y axis, go ahead and do that now. All reals where x cannot equal what? -3. Vertical. Where do I look at for my vertical? Denominator. And so what do I get? X equals, I graphed it in right away just so I can remember the whole even odd business. What is the multiplicity there? 1, so even or odd? Odd. Make notes to yourself, guys, because I often get, like reviewing for the test, and I'll have kids saying, how do you know if it's odd or even? So you're making notes to yourself. How do we know whether that's odd or even? We look in the what again? Denominator. And we look at the multiplicity. All right, horizontal limit as x approaches infinity. Y equals what? 2. Does everybody see that? All right, so I'm going to go up 2. And x-intercept, we said it equal to 0. 0 equals 2x plus 1 over x plus 3. What's going to happen to the bottom? So you'd subtract, divide. What's your x-intercept? -1/2. Y-intercept, plug in 0. What do you get? 1/3. Okay. Negative 1/2, 1/3. Okay, now I will tell you right now, you do not have to do test values on this one, and I'll tell you why in a second. Okay, do we have to do test values? Okay. The only time you have to do test values is when it's like this, when your horizontals at y equals 0, because you don't know whether you're top half or bottom half. You don't know whether you're top half or bottom half, because your horizontal is y equals 0. Now, when your horizontal is not 0, and it's a number like 2 or a half or a third, you don't have to worry about it. I'm going to explain why. Are you ready? Do you see the top half and the bottom half? Now, do you agree the top half and the bottom half is not made with the x-axis like the other two? The top half and bottom half is made with this red line that is y equals 2. Yes or no? Okay. Now, as before, the graph is either going to be all at the top or all in the bottom. It's going to be all at the top of the red line or all underneath the red line. Can anybody tell me your guess on where it's going to be? Top. Why the top?
Because the x-intersection is right.
Because what? Because the one on the right has to be the bottom and it's opposite? Okay, so you're using your tools, these tools over here. What did you say?
I said because the points are on there. Right or wrong.
Oh, okay, so what you were saying over here, same reason? Yes? Okay, and the other reason is we don't have any x-intercepts over here. Do you see that? I'm going to cover this again. It's either all above the red or all below the red. If I were below the red, I would do this and end up crossing what? Do I have any x-intercepts over there? I can't force them in just because I want to, so I'm forced to be where? The top. Do not use a test value. If you do, you're going to end up messing it up. All right. Questions? Okay. You use the test values only when your horizontal is what? 0. When your horizontal is 0, you use a test value. So make a note to yourself. Horizontal is 0 is when you use your test values. Because you don't know top or bottom because it's on the x-axis. So you can't use your intercepts. Yeah, there's no intercepts here. But if I was at the top, I wouldn't touch the x-axis. If I was at the bottom, I wouldn't touch the x-axis. So intercepts don't help me on this one. Do you see that? Where intercepts help me on this one because the horizontal is not on the x-axis. So I know I can't be on the bottom half because there are no x-intercepts. Okay? And then odd means same direction or opposite. So I'm coming from down here. And I forgot to ask, this negative 1/2 was a cross or a bounce? It came from the numerator. That's a cross. And so I do, oh, and I'm approaching this, and I only cross it when necessary. So I come up, I hit that, and is there any reason to cross that red line? No, that's your graph. And one more before I move on to the last one. Any questions on that? None? All right. Y equals x plus 1 squared, x minus 2, over x plus 3 squared, and x minus 4 cubed. Do we have some different multiplicities here? Yes. Finally, yes. All right, what's your domain? All reals, x cannot equal -3 or +4. Any reducing, I forgot to ask that first. No. Okay, vertical, x equals, okay, now -3 is here, so when I graph the x equals -3, I do have to make note whether it's even or odd, and what is it?
Even.
Why is it even? Multiplicity is 2, so since it's even, I'm going to put even here, and what does even mean? Same direction? All right, what is the second asymptote? X equals 4, and what's the multiplicity here? And that's even or odd? Odd. So instead of even and odd, I'm going to put m equals 2 and m equals 3, and you know m is 2 is even and 3 is odd. So I'm going to go over to 4. 1, 2, 3, 4. And put a little note there that that is odd. All right. Horizontal. Top heavy, bottom heavy, or the same? Bottom, do you see that? What's the degree at the bottom? What is it? 5 at the bottom? Or 3 at the top, yes? 3 at the top, 5 at the bottom, so y equals 0. So since it's y equals 0, is this one that I have to do a test value? Yes. All right, and x-intercept, set it equal to 0. What always happens with the bottom? So really, is this really what you're processing here? Yep. Negative what? -1, and what's the multiplicity? Which means what? Bounce. And what's the second x-intercept? Which is multiplicity of 1, which means it is a cross, and then your y-intercept. Plug in your zeros. It comes out to be a crazy, wonky fraction. Zero plus 1 squared, 0 times -2, 3 squared, 4 cubed, or -4 cubed. Anybody have it? Positive 1 over 288. All right. 1 over 288. He plugged it in. So 1 squared is 1 times -2 over 3 squared is 9, and -4 to the third is -64. Yeah. I got 288. Oh, for 9 times 64? And then the 2 reduces with it. Yeah? So yes. All right, we're good? Okay.
Next unit.
Well, we haven't cracked it yet. All right. Okay. 3 halves. Left, middle, right. Let me mark in my intercepts. -1, that's a bounce. +2 is a cross. And that's like a really small number in there. Okay. Far left. Do I have enough to just say, oh, it's all at the top? Or, oh, it's all at the bottom? No, because the horizontal is 0. I have to use a what? Test value. Pick a value to the left of that red line. X equals -4. I heard -5. Would -5 work? Yes. Plug it in. All you're caring about is whether it is positive or negative. So do that now. What do you have? Does it come out to be positive? All right. Okay. And then even means opposite or same? Same. So I come here, and what do I do with that? Bounce. I hit that. Do I come up like a U shape? No, because I have this other x-intercept to hit. Do you see that? So your x-intercepts guide you. After I hit that x-intercept, do I have anything bringing me back up? So will I now go down towards that red line forever? And odd means same or opposite. So top half or bottom half? Top half. And that is your beautiful graph. Yes?
How do you go off to find, like, the odd on the right side? How do you know the top or bottom?
Because we use the even and odd. The even and odd that we got from the multiplicity is 2, it's even. Multiplicity of 3 is odd. So we go off of that. Odd means opposite direction. So if this one's going down, this one's going up.
So if the odd one was even, it would be opposite.
Then it would be at the bottom. Mhm. Ask me a question.
Can you explain how you got the horizontal axis?
The y equals 0? Can anyone explain that? How we got y equals 0? It's bottom heavy. So you do the top heavy, bottom heavy, same. Degree is 3, degree is 5. And 5 is bigger than 3, so bottom heavy is always 0.
And what would happen if it was the same?
Then it would have been like this one up here. But we like it when it's the same because you don't have to do the test value. When it's the same and you take the leading coefficients, it's either top or bottom. You don't have to do a test value. You look at your intercepts as a guide.
You just take the leading coefficient of the numerator when they're